All right, good afternoon, good morning, everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presentation today is getting to grips with performance for Azure SQL Database. Our presenter is Anat Dror, and she'll be taking things over here in just one moment. Before we do that, though, I did want to let everyone know that our sponsor for today is, there we go, it is Quest. Quest has been sponsoring us for about the last 4 months, and it's really helped keep the user group, the virtual group, going. There will be a short presentation by Quest here at the end that I encourage everyone to take a look at and have some Q&A available so that you can find out more about what Quest is offering here. The PASS Summit is coming up here in just a few months. I encourage everyone to go. This is going to be, I think, my 7th or 8th year that I've gone to the PASS Summit. Actually, it might be more than that. If you haven't registered yet, we do have a virtual group registration discount where you can get $150 off of the current registration cost. That code is right there on the screen. I'm not going to bother trying to say that. But if you do that, and we do get enough people that register through this user group, we will have a registration that will actually be up for raffle. So I encourage you to A, go to the summit, and B, use the discount code so we can make that available for someone. So this virtual group is the Cloud Virtual Group. There are a number of virtual groups that are sponsored and put together by the PASS organization. There's some that are language focused, like Global Chinese and Portuguese, and others like ours are more focused towards different technology areas like the cloud or data architecture or in-memory tables. So there is a lot of content that's out there. Most of these, I think everyone puts their sessions up on YouTube after they are complete, so you can look for upcoming sessions or even look at all the historical sessions that have been put together. With that, those are the announcements for today. So Annette, I'm going to make you the presenter, and she will take over and present on getting to grips with performance for Azure SQL Database. Just got to get to the right screen here. All right, Annette, you are now the presenter.
Thank you, Jason, and hello, everyone. As Jason said, my name is Anat Dror. I'm based in Israel. This is me. I'm spent the last 12 years or so building a performance monitoring tool, so I'm super excited to be here today talking about performance for Azure. I encourage you all to use my contact details listed here and send me any thoughts or comments after the presentation. That would be great to hear from you. So before we start, I'd like to ask you this. Since, as you know, this Azure SQL DB is a managed database service. And as we know, managed services are usually allowing you to scale on demand. Azure SQL DB is no different. Also, most of the cloud providers and Microsoft within them also claim to use artificial intelligence and harness the power of the cloud to provide automatic tuning. So if we have both of these, ability to add resources on the fly as we needed, and the platform ability to automatically tune our workload, why do we even care about performance? Should we care? Isn't tuning SQL just a thing of the past? I'll spend the rest of the presentation checking with you if this is indeed the case. So our agenda today is first to be convinced that we do care about performance, and I'll show you why and how. Spoiler, one of the main issues related to performance is cost. And so we will drill to see what cost includes depending on the configuration we choose. And in the rest of the session, we will see what we should monitor to ensure top performance and how. I will also show you some of the out-of-the-box tool Azure provides to help ease our work with that. Finally, I hope to leave you with some guidelines about best practices to consider while moving to the cloud if you're not already doing that. Okay, so why should you worry about performance in Azure? First and foremost, cost. The more resources you add, the more you pay. That's obvious. And to ensure you're not paying too much, you need to monitor what you're using. You can reduce the cost by tuning your SQLs. So as critical as performance is for on-premise database, it becomes even more critical when in Azure, because you actually pay for that. And we'll see, we can actually see here what you pay for that. This is just a Microsoft. Oh, you're not seeing that? Hold on. This is the vCore model and DTU. We'll talk about that later, but just want you to see that the more resources you use, obviously more money you pay. So there's a great incentive of keeping that down. Second, throttling. Unlike, or not in all cases as in on-premise databases, the Azure engine will sometimes cancel or reject requests if they don't have the resources needed. And so this is done obviously to ensure that all requests receive a same service level, but it does mean that queries can be just canceled. Not sure if that is worse or better than just waiting for that, but your application certainly needs to take that into account, and avoiding that becomes a goal. Even though cloud provides, and Azure specifically, provide the ability to scale up, there is a limit to that as well. And so ensuring you within your own service, the service tier you selected is one of the goals, even if you do have the money to spend on that. And last but not least, response time. Ensuring your customer have the lowest response time possible is, of course, remains the most important thing, and Azure is no different. Now, we will see that there are things in this platform that that help us tune faster and maybe easier, but it's still on our ends as the DBAs to ensure that this is met. So what affects application performance? First and foremost, even before we get to the actual service tier you choose, it's how the application is designed, right? Chatty behavior means each connection to the server, application is using a lot of connection to the server. And because the database is in cloud, that means you're inherently going to get latency by going to the internet, especially, of course, if your application is on the cloud as well in the Azure services, then you don't get this. But if you are using on-premise to connect to the cloud, then you're probably exposed to this behavior, and limiting these round trips can reduce response time a lot. Obviously, other stuff as in the on-premise database also affects the workload. The size of the database, the amount of records you read in each request, or the amount of data you insert, a number of concurrent transactions affects both log performance as well as concurrency. If the schema is not designed to optimal performance, that can of course affect how well application responds. And concerning concurrency, as we said before, both locks and deadlocks. All of these are at the hand of the application and our ends as the DBAs. Nothing to do or little to do with how the database is handling itself. And then the next thing is, of course, the service model. And we will see that depending on the server model also affects the hardware that is used. And of course, the more money you spend, you can get a better hardware that provides a better performance. And you need to check whether you want to pay for that or not. So how do you check? Oh, before that, when do you want to work? When do you need to worry about performance? So this is probably obvious, but assuming you are not already in the cloud, before you even move there, and after, of course, you ensure that the limits for Azure meets your demand, you should also check if what service tier you need to use when you first go to the cloud. Because while you can certainly scale up or down if you misconfigure that, there is latency when changing between service tiers. So better to have it at least close to what you really need. And I'll show you in a bit a way to help with that as well. And of course, ongoing and during the move and while doing the acceptance test, that's also when you worry about performance. You check constantly that you are meeting your requirements in terms of performance. But then, what is good performance? Is there a specific measure that we can use that tell us that this is good? If DTU or CPU usage is under 90%, is that okay? I/O wait time? All of the above? Well, I won't leave you hanging. I think the measure of good performance depends on the throughput you are able to get from your database and the response time. And the application, the database should provide you the throughput you need, number of transactions per second, batches per second, in the response time that your user will find predictable, and in ensuring that response time is always the same. So you define what is good, and you can, for example, say, I want 95 of my transaction to finish at less than a second. But that, of course, depends on your workload, which is why no one can tell you what a good measure is. But I do encourage you to measure your performance based on these metrics. And in a few slides, I will show you some of my best way to figure that out. So, purchasing model. When you go to Azure, there are two purchasing models that you can use, DTU model and vCore model. The DTU-based model represents a pre-configured bundle of compute, memory, and storage resources designed to drive different levels of application performance. DPU blends this measure in ratio determined by an OLTP benchmark that Microsoft did, and it's designed to be a typical real-world OLTP workload. The idea is that doubling the DTU will double the resources available for the workload. Now, in a perfect linear scaling workload, that can also mean doubling the throughput, but that, of course, depends on the application. DTU model is best suited for simple, if you don't want to spend too much time determining how many CPUs you need. You just want to give a number and start. It's simple to understand, right? The more DTU you have, the more resources you have. The more DTU you have also increase compute resources and storage resources. So you cannot say, I want more storage, but I don't need any more compute resources. vCore model, on the other end, was introduced as a request by customer to provide a way to separate storage and compute resources, so you can scale each of them individually. In this model, you basically say how much storage you need and which type of CPU model you want to use, how much of these CPUs you want to use. So it's more suited to a more demanding workload, so to speak. Each of these models have their own service tiers. Some of them are provide similar workload, so critical service tier in vCore is somewhat the same as a premium service tier for DTU, but the service tiers at the ends, the basic and the hyperscale, do not have a match in the other model. So basic is just too small for vCore, which is why you can start with DTU in small, and hyperscale designed for a very high workload is not something that you can achieve with the DTU model. Also, the service tier dictates, as we said, the hardware that is being used and the functionality. In some cases, the functionality that you can use is only available in some of the tiers. Let's see an example. So this is the service tiers of the DTU. It ranges from basic to premium. And as you can say, each of them provides more in terms of the CPUs that you can use, the DTU limits you can go to, the storage, the hardware. With basic and standard, you only get a disk that allow you for 5 milliseconds latency per read or 10 milliseconds per write. But if you pay for premium, they guarantee a 2 millisecond latency. Same goes with throughput. And as I said, you see in premium, you can use the column store index and the in-memory LTP, which is not available in the other tiers. So know what you need is important before you even start. Also included within the cost is how many backups you get, what kind of high availability you are allowed to use. Some of this you need to opt in, like geo-replication. Number of concurrent sessions and worker thread is also limited by the service tier. TempDB quota, even though you can't see TempDB within your database, it's there. You are allowed to use temporary tables, but you do need to monitor the use of that, as it is limited depending on the service tier. Same goes for in-memory storage if you're using that. So I promised earlier that I will show you a way to calculate how much DTU you need for your workload, and it's not actually me providing it, it's of course Microsoft. Here is the link where you can look for that. It's basically a command line exe or a PowerShell script that you can download. It will collect these performance metric here, processor time, logical disk, performance and log bytes rate, and it will then, and of course you need to run this when a typical workload is running, and it will then upload the data and will give you a measure of which service you need. Actually what it provides is a chart that depicts the percentage of time that the database resource consumption fit within the limits of each service tier, and that will allow you to select which service tier is most suitable for your workload. So that's a good thing to know that exists. And also, if you want to see how much will it cost, there is another calculator for the cost as well, where you select the region, because yes, cost depends on the region where the data center you select, the type of the database, and all other model definitions you provided. Okay, so now we are convinced, hopefully, that cost is a factor. But how do we, so what do we need to measure and how? So first, as I said, we need to measure the performance we want to have. And as we said, I recommend to use response time and throughput in order to track that over time. You need to do that beforehand or during the times that you think performance is good, to establish a baseline of 1 hour or different hours or even longer than that, and save that so you can compare to this baseline afterwards. In regards to throughput, it's basically you can collect that in the same way you do with the on-premise database. We'll see shortly how, but it's performance counters that are also available in Azure. Similar for response time, so you can track current executing queries using the exec request DMV. You can check the average response time in the query stats. Again, same as we do with on-premise, but with Azure we also have Query Store, and we'll talk more about the Query Store later. But for now, what you need to know is that Query Store can include a repository of all the queries you run at a specific time, and you can query what the response time was and establish a baseline based on that. And what I mostly recommend is to use the perf batch response statistics object, which is very interesting and not widely known, and surprisingly can be used in on-premise as well. So if you're just wondering if going to Azure is a good thing, you can start by measuring that on your on-premise database too. So I want to show you this. Hopefully you can see my SSMS screen. So what you see here, I'm connected to a Quest SQL DB, that is a Azure SQL Database, single database in the cloud, and I just ran a query against the DMX query stat to give me a list of the statements ordered by the response time. This I can use to either tune these SQLs or just save them as a baseline. This holds information about all runs, or at least those that were not evicted from the memory since the database was created. Here in the query, I only asked for the last 60 minutes or queries that were run during the last 60 minutes. Of course, you can enlarge that and hopefully, but the amount of data that retains here depends on the memory usage, of course. So that's obvious. But as I promised, there's a performance object called batch response statistics, and in that, what Microsoft provides is a way to see how many batches ended within 1 second, how many batches operated between 2 and 5 seconds, how many batches finished between 5 and 10. And this is a very easy, straightforward way to measure the performance in a more granular way, but in such a way that you don't lose the forest out of the trees, right? So we ran it into samples so we can find the delta between these samples, and we can now see that we ran one batch between 10 and 20 seconds. That was its response time. If we track that over time and save this information, we get a pretty good idea of how well is our workload. So we get both batch rates, right, but also how well they perform. So this is the way I think is the best and most straightforward, but the other ways are also good and provide more details, depends on what you want to do. Just to wrap it up nicely, of course we can also check performance counters, SQL statistics, and SQL database for the information about batch request rate and transaction rate. What we did here is 2 samples in 10 seconds to just show us the rate. I have here a very low noise on the background. As you can see, 3 batches per second, 36 transactions, not very high. Okay, so back to our presentation. Now we know how to measure performance. We want to see what resources are being used. Sorry. So assuming that we used the DTU model, the first thing would probably be to monitor how much DTU we currently use. And luckily for us, there is a very easy way, DMV, that store this information, and it doesn't only store DTU, it also stores how much memory we used, how much log, what's the log rate, how many logical I/O we did, how close are we to hit any of the limits that is determined by the services we provided. For TempDB, we need to query some other DMVs, and we will see that in the next demo. So first, we can query the DM resource stats. This view is available within the database context of Azure, and it basically have a record every 15 seconds. In this query, I aggregated that to every minute, and I'm running it for the last 5 minutes, right, to see data in 5 minutes. But since this is constantly added, you can query that for any time period you like, and in even greater details than what I show here, right? I added that to a 1 minute rows, but it can go as granular as 50 seconds. So you have 4 samples within each minute and not 1. As we can see, the average DTU percent over these 5 minutes, not very high, maximum of 22 in my server. But the memory usage percent is pretty high. So I'm probably going to hit this limit, and maybe my queries are limited by that as well. Max worker percent and max session percent are way below anything I should be worried about. Very easy. If you want to see what is running within the system, well, you can just use the regular exec requests sessions, DMVs, to see what is going on. As you can see, only 3 sessions are active, one of which, by the way, is this DB44, which is actually a collector of Azure itself. But the rest is the workload I'm running behind the scenes. What we can also do is check whether any of these is using the TempDB and how much of the TempDB is using. So if you find out that you have a problem of TempDB, you can use that to see which session is using that. And last, we can use, as I said, the query store to find out what are the top statements by duration during the last 5 minutes, or by anything else, right? We can order by anything we want. And there are pretty good information in the query store regarding the performance of our queries. So we can, if we know that our workload is using a lot of memory, we can order that by the max query used memory. More about the query store as we continue, because there is a lot to do, a lot to find out. Throttling. I mentioned that earlier. Again, in some cases, when the request that is going to be made is not going, Azure determines that it cannot properly service this request, it will just reject that, and the user will get, the application will get an error similar to this one, 4501, service is currently busy, retry. So of course the application needs to retry, but besides ensuring that resources are not close to the limits as far as you can in advance, you should probably also monitor for these errors in some way. In Azure V11, we had the sys event log DMV that listed these events, but if you create an Azure database now, you only get version 12, and you can't use the sys event log for managing the throttling. You can for other things, but not for that. So the best thing would be to create an extended event that will gather all these requests, so you know if you are hitting these limits, unless of course you have another way to measure that. By the way, not every limit will create a throttling. Some will just wait. So monitoring the resources is a good regardless of throttling. Waits. So with on-premise database, one of the best way to monitor performance is to look on what the workload is waiting on. And of course, the most obvious wait is lock. But there are so many wait events, and looking at them really provides a better view to understand what is going on under the covers. And this method is not unique to Azure. It's been around for SQL Server for ages, and it's all about managing queues. So you need to know how many requests are running, how many are suspended because they are waiting for something, and how many are not waiting for anything, just to get the CPU. And so there are, as I said, there are many weights, and more with each SQL Server release, of course. But what Query Store did is now there is a out-of-the-box categorization of the weights to help us better classify all the weights that should be addressed in the same way. And so you can query that based on the category instead of by the actual weight types, although that is not available in the Query Store, but it is available in other means. Take into account that idle category includes weights that can be ignored, but they are categorized as idle, and CPU usage is not weight, right? So measuring performance CPU consumption cannot be done in that way. There are many ways to monitor the weights. We can use the unique view sysdmdb weight stats, which is available only in Azure, and provides similar view to what sysdmos weight stats provides for on-premise database or regular database engine database. I keep saying on-premise, but that's not true because you can always install that on a VM in the cloud. Again, DMDB weight stats aggregate the weights since the database was moved or started. If it was moved between replicas, then all the weights will start from 0. But for normal operation, it will just be the weights since the database started. You can measure the weights at the session level using the DMExec request, again, exactly as the normal database engine. And starting from 2017, and also, of course, in the Azure databases, we do have the DMExec session weights that can help us monitor the weights aggregated at the session level. So as long as the session keeps running, you do have the way to figure out the weights for that session as well. And of course, we do have the weights in the Query Store. Again, it was introduced recently with 2017 and available for Azure as well. Query Store weight stats. And let's see a demo of that as well. So as you can see, DMDB weight stats, just the weights without the categories, and you can of course order them by the wait time MS, figure out what is going on, what's most affecting the database. If we query exec session weight stats, we have multiple rows per session, and again these will only stay here and be aggregated as long as the session is active. If you want to use the Query Store, we can do that, but surprisingly nothing is shown. So that's very weird. Let's see what is the option for collecting weight stats in the Query Store, and we do see that weight stat capture mode is off. So here's the first thing about Query Store. By default, it does not collect all the weights. It only collects CPU. If we want to make it monitor that, we need to alter the database to do that. And now, hopefully, we will get more information. Probably need to wait for a bit. So it will gather it. Okay, we'll get to that later. Once we do have it, not sure what happened here. We could query that to see all the queries that relates to a specific weight, which is something that we will not be, we didn't have the ability to do in the past. We'll probably see what is wrong with my query store when we go later to the Azure portal in our next demo. I suspect that it has stopped collecting data. Okay, but trust me when I say this will work. Of course, contention should be monitored in the same way that you do it for a regular SQL Server using the DMexec request or the tran log, waiting tasks, etc., and use the extended event to get details about deadlocks. For all the other things, you could say that automatic tuning can help you, but for contention is one of the things that no machine can fix for you. It's unless fixed intelligently, right? You can always tell the computer, okay, so if something is locked for too long, just cancel it, but then it will happen again. So monitor for contention is an important part of making sure performance is kept in a good way. And you can also use your favorite tool for benchmarking your environment and saving these as a nice graph that correlates the response time with the user loads and compare that between times. Quest does have a tool for that, but I'm not going to show you. I'm sure you have your own favorite benchmarking tool. So we talked a lot about the query store, and I do want to point out some of the things, the good things that the query store provide us. So query store, as the name dictates, is a repository of queries, and SQL Server can automatically capture history of queries and save that in the store for every query and its plan. At a specific timestamp, you can find out what is run, how much resources it used, what did it wait for. It's just a wealth of information. It is returned over time. It can, as I said, it's aggregated by a time window, so you can pinpoint, okay, so just show me the queries that run between 2 and 3 yesterday. It is enabled by default, and we'll see why it's not enabled for me, but it's not collecting everything by default. It is collecting only the top queries by default. If you wanted to make sure that everything is collected, I had before the query mode, and I set it to all, but need to consider that everything, that the more you want to collect, the more storage it will take, and that storage is part of your database storage quota. So if you paid for 10 gigabyte, part of that will be reserved for the query store, and of course you can limit that amount as well and monitor that. So it's a trade-off between being able to know what's going on and paying for that. And there are out-of-the-box reports available in SSMS. I see that we are going to run out of time, so I'm not going to show you that, but I do encourage you to look for that. Provides great out-of-the-box views that just show you what your workload is, and allow you to enforce plan or track a specific query without knowing anything about SQLs. You have here some of the use cases, and the list goes on and on. The minute you have the ability to see what queries, what plan they used, what parameters they used, really any question you once had can find an answer in the query store. And it is available by default within Azure Database, unlike the regular SQL Server. This is the query store schema. We won't go into details, but obviously you can find the text. All the statistics are saved in the query store runtime stats, and all the weights in the query store weight stats. Hopefully all my demos for this presentation can be available for you, and you'll find there some example of how to use the query store for some of the use cases we discussed before. So again, I'm sorry, we're going to skip the demo for the query store. You know what? Let me just show you where to find it. So you see here, query store. Sorry. And it does provide you the list of queries that the plan have a regressed plan. That means the same query with the same plan, but in some cases it performs really well, and in some cases not so well. You can see the overall resource consumption and so on. But what I really want you to see is the query store status. And we see here, so we didn't use all the space available for us. The operation mode we requested is read-write, and it is read-write. That's very, very good. All of that is what you would need to check in order to make sure query store running smoothly for you. So whenever there is a space situation, or you see, the query store can go as high as 337 megabytes, but because I limit my database size to 100 gigabytes and I'm currently using 63 megabytes, oh no, it's very small, so forget about it. But yes, it is part of this limit. So you need to track down and make sure it doesn't go over the limit. Also, any problem that can happen, there is extended events that you can monitor to find out if something is going wrong with the query store. Because hopefully I convince you that when you do have the query store, you have eyes inside what is going on in the database, and if it's not there, you don't. Azure also provides you out-of-the-box tools that can help you at least look at the workload of your database without caring about SQLs, so easier and in some case quicker. So let's look at the portal. No. Here is my database. And right away I can see DTU consumption over time, and you can change the time frame. But you also have here the metrics, where you can select any metrics we already talked about, CPU percentage, deadlocks, and so on, and have them on a chart. You can choose the chart type, very easy, and you can change the time frame. So this is last 24 hours, but we can change that to meet what we currently want to see. So that's one thing I think is worth knowing. The other thing is the query performance insight. So as long as the query store is working as designed, you do have here all the information about the queries, and you can automatically see the top 5 query based on whatever metric you choose. This can be configured, by the way. So you can select up to 20 queries over a different period of time and aggregate that based on max instead of sum. So you can see what is the top for each of these. And then, of course, you can drill down to the query itself to see more details. Now, automatic tuning that we talked about at the beginning is the ability for Azure to automatically fix some of the issues that are happening a lot, like missing indexes or indexes that are not being used, so they can drop them, or force a plan, like we showed before in the request query. If Azure determines that the plan was better in the past, you can then force that plan for the query. And you can choose if you want to do it automatically or just get a recommendation. And if the recommendation was available, we would see it here on the query page. But we can also see a list of all the recommendations that exist. And the way Azure does that is that it monitors, for example, create indexes. It just monitors the missing indexes DMV that is available for a long time. And then it's, if this recommendation is repeats itself, and they can check that based on the data that's available in the query store, they can add the index, so they are not adding any index. But then they go into a phase of validating the index, making sure that nothing has deteriorated, and this is the period of validating. Once they determine that the performance has improved, this will go into status validated or reverted back. Here you see a past recommendation for creating an index that failed because we didn't have the capacity. So this is a very easy way to get a database to do some of the performance tuning for you. And I hopefully I convince you that it won't solve all of your problems, but it can certainly help. And this is an easy way to get to this recommendation. And of course, this is a DMV like any other, and we can query the recommendations directly from T-SQL. We almost finished our presentation. So I just want to leave you with some best practices. The most important one, I think, is to know your system. Measure frequently, know what user load is normally there, what is the response time that you normally have. If you have the information about how many batches and what is their normal performance, that is best. Choose the correct Azure platform. elastic pool or managed instance, depends on the workload. Reduce network latency if your application works on-premise and connects to the cloud. And tune as you do with all databases, and Azure is no different. And of course, this is an ongoing procedure, so we are not left out of work. You do have here resources so you can further read everything I mentioned here, including the calculators. So Jason, back to you.
All right. Thank you very much, Anat. What I'm going to do now is make Peter the presenter so he can go over. He's got a quick presentation on some quest items. So just 1 second. There you go, Peter.
Thank you very much. And thank you, Anat. And hopefully everybody's got a really good feeling of some of the key performance issues and particularly cloud database monitoring, but of course they apply to all of your workloads. It's really great to see some really great solid tools in there from Microsoft as well, some free tools to get you up and going. We've also got some performance monitoring tools in our bag over Quest. We've been working on them for the last 20 years, and that's one of our key R&D team on our new Spotlight Cloud platform. What's kind of unique about Spotlight Cloud, it monitors your on-prem and cloud workloads for SQL Server, and what's kind of unique about it is that it's actually built in the cloud itself. So the back end for this right now is built in Cosmos DB. It's a completely SaaS application, so it's hosted and it comes with all the benefits of something like SaaS. It's really easy to set up and going. You've no headaches with storage or maintenance. That's all taken care of for you. It automatically updates, and you've no on-premise repositories to take care about, or cloud repositories for that matter as well. And it's one thing to kind of bear in mind as you start looking at performance options. The free tools are great, but sometimes they're not quite free because you've got to store your data behind that. So if you're, for example, keeping your query store historic data for a long period of time, watch out for Azure storage costs there as well. So factor those kind of things in. The free tools are brilliant for getting up and going initially, especially when you've got low numbers of databases to deal with. Over time, as things get a bit more complex and hairy and you get more of these instances on board, or whether you want consistency in terms of single pane of glass for on-prem and cloud and so forth, that can become a little bit more complicated and involved. Also, you'll find that you do quite a bit of configuration up front. So as your environment gets that bit more complex, or as you want to monitor more, you've covered off the basics with your few tools, which is great, but now it helps to have a lot of much more out-of-the-box capability so that all your alerts and monitoring are set up out of the box, your diagnostic workflows are set up out of the box, and you get more management capability to be able to manage more instances or more databases more consistently. What we've learned as we've built this tool ourselves on cloud workloads is that, as Anat alluded to, your performance struggle is constant, right? So we are constantly monitoring our costs on Azure as we build and scale out this system. As you can imagine, where you've got lots and lots of users with potentially hundreds of thousands of instances that they're monitoring, both the compute and storage costs behind this can escalate very rapidly. So we're constantly looking at our configuration and our workload characteristics to maximize. And even when you're starting out, some of the basic concepts like using managed instance or elastic pool. So okay, I want to use elastic, but what particular workloads should I mix into that pool? And making sure you've got the right blend of workloads so you get the maximum out of that pool and you get the maximum bang for your dollar. So I remember being at SQL Bits and Pass over the last couple of years, and a lot of doom and gloom about what the future of the DBA is in a cloud environment or in a DevOps environment, and what will be our role. Our role is changing. There's no doubt about it, but it doesn't make it any less relevant. In fact, right now, as we start going into our quarterly reviews and start looking at something like our Spotlight Cloud infrastructure, our input from an R&D team is as closely scrutinized by our CFO as our marketing team or our sales team, because they have a direct and tangible connection to our P&L. So they're now seen as critical, absolutely mission critical resources to make sure that our costs don't get blown out. So it's kind of an interesting perspective when you start looking at performances to frame it in that way internally. It can be really, really good to focus the mind of your taskmasters to show them what a big impact this has in terms of your overall cost. So very quickly, I'm going to give you a very quick overview of Spotlight Cloud. As I say, hosted solution gives you very deep performance and analytics to be able to dive into SQL Server instances of any shape or size. We're looking at here, this is kind of an overview where you can get an overview of your performance help, and you can deep dive into various different diagnostic drill downs depending on the nature of an issue that you have. You get a detailed list of alarms. We've got no blocking going on here. Let's pick something that's a bit thicker. So we're going into this particular one. We can see our CPU is maxed out here. We might want to delve into why that is, and if we were to go into diagnostics here, if I hit CPU here, it'll bring me right over to the associated server that is deployed on, or I can go into the actual workload analyzer here where I can cut and dice my workload. And as that shows you again, you can get an awful lot of the analysis here yourself, either by scripting it or by some of the free tools. But when you want to get at something very, very fast, it helps to have some of these diagnostic drill downs here framed for you so you can click through it very, very fast. You know, in the heat of the moment when the alarm is going off and your application is down, you want to be able to drill in very, very quickly. So this is a really great example in workload analysis where we've got this multidimensional analysis, and we can cut and dice our workload by various different dimensions. We can take a CPU or an IO-centric view. If I click on these, it changes the dashboards here to be more IO-centric or CPU-centric, or I can look at my overall workload characteristics. I can drill right down and cut and dice that workload and say, well, what applications are consuming most of my workload? Here we just have jobs running to simulate characteristics of workload. I can drill right into a top SQL or a top batch or a top database or a top user for that particular program for that particular instance. So you can cut and dice that workload very quick, and I can go right down into, say, here if I go into my top SQL, look at a SQL statement, I can view that SQL statement just you had with some of the other tools, but then I can go in and actually look at the plan as well. And all of this is happening in my browser. Right, so whether it's an on-premise workload or a cloud workload, I can remotely access this tool. So if I get alarms that are hitting me in the middle of the night, I can log into my browser and start troubleshooting there and then, meaning that I don't have to up and leave or VPN into my Office tool just yet. I can start troubleshooting there and then. There is a ton of detail here that we'd love to show you more on, but some of the key things here, if you go to spotlightcloud.io, you can sign up for this tool. There's a free 30-day trial. There's also a freemium version of this, which is much cut down in terms of diagnostics, but gives you some basic diagnostics there that you can utilize as well. But once you sign up, it doesn't take much effort at all. You just sign up and sign in. When you do, you'll see some sample instances here. These are live workloads we've set up so that you can get to evaluating this tool without any effort whatsoever or any installation. And then when you're good and ready to monitor your own workloads, for on-premise workloads, there's an easy installation. You download a data collector which uploads data to this repository, and you can be up and going in less than 20 minutes with monitoring your own instances as well. There's a ton of detail here to look through, lots of different interesting diagnostic drill downs from storage, any aspect of storage where it's database, file, indexing, fragmentation and so forth, tempDB usage, availability, and much, much more. So here you just get, you know, what Nat showed you again, the basis of a lot of the performance analysis and diagnostics you can get from the free tools is great. Here it's all pre-configured, about 150 to 200 alarms out of the box pre-configured with alerts that you can go and customize, and then you can create things like alarm rules to decide what remediation to execute on an alarm going off. So for example, if you've got a script, a PowerShell script or a SQL script for a known issue, you can execute it to kill an issue there and then. Or you can do things like blank outages during planned outages and so forth, so you don't get alarm fatigue. So we'd love to tell you more about this, but I'm not going to take up much of your time today. It was great to hear Anat going through the tools and the technologies and the issues around Azure performance. And I'll leave it back to Jason there just to field any questions you may have had there during the presentation.
All right, thanks a lot. Actually, the one question that we had was answered right at the end by Anat, so I think we are good. I'd like to thank everyone for coming out today, and very shortly we'll have this presentation up on YouTube for folks that either missed it today or want to go back through to catch some of the details of the presentation. Thanks again, Anat. Thank you, Peter, and thank you everyone for attending. And with that, I'm going to close out today's session.